This question is to find the general indefinite integral of a piecewise function. Let the function g of x be defined as follows. For all x greater than or equal to 0, g of x is equal to 2 times x minus 1. For all x less than 0, g of x is equal to negative 2 times x minus 1. Find the general indefinite integral of g of x with respect to x. Make sure your final expression is continuous at x equals 0. All right, let's break this down carefully. First of all, understand the function's shape. This function, g of x, is defined in two pieces. When x is greater than or equal to 0, it's equal to 2 times x minus 1. When x is less than 0, it's equal to negative 2 times x minus 1. So visually, if you sketch this in your mind, it's going to look like a sharp V shape. The left part of the graph, for x less than 0, is coming down toward the point 0, negative 1. And the right part of the graph, for x greater than or equal to 0, is rising from that same point. That point is the tip of the V, and it lies on the vertical axis at negative 1. That tells us the function is continuous. The graph doesn't break, but there's a sharp corner at x equals 0, so the function is not smooth there. Next, integrate each piece separately. Now let's find the integral piece by piece. First case, for x greater than or equal to 0, we are integrating the expression 2 times x minus 1 with respect to x. The antiderivative of 2 times x is x squared. The antiderivative of negative 1 is negative x. And of course, we add a constant of integration, which we'll call capital C1. So in this case, the integral is x squared minus x plus C1. Second case, for x less than 0, we are integrating negative 2 times x minus 1 with respect to x. The antiderivative of negative 2 times x is negative x squared. The antiderivative of negative 1 is also negative x. And we add another constant of integration, which we'll call capital C2. So in this case, the integral is negative x squared minus x plus C2. Then, match the two pieces at x equals 0. Now, because we're looking for a general indefinite integral that is continuous across the entire domain, we need the two expressions we just found to match up at x equals 0. So we'll plug 0 into both expressions and set them equal to each other. In the first case, at x equals 0, x squared minus x plus c1 becomes 0 minus 0 plus c1, which is just c1. In the second case, at x equals 0, negative x squared minus x plus c2 becomes 0 minus 0 plus c2, which is just c2. So for the integral to be continuous at 0, we must have c1 equal to c2. That means both constants are actually the same, so we can just call them capital C. Final answer is, for x greater than or equal to 0, it is x squared minus x plus capital C. For x less than 0, it is negative x squared minus x plus capital C. When you're integrating a function that is defined in pieces, always treat each piece like its own problem. Integrate them one at a time. Then, check that the two answers agree at the point where the pieces switch. Usually that means matching constants, so the two expressions are equal at that point. And lastly, think about the graph. Just having a mental picture, like we did with that V shape, can make it so much easier to keep track of signs, slopes, and where things should match up. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel and turn on the notification bell. Press the like button. Thank you so much.